All right, so to continue on with questions 10, 11, and 12, we're going to be using tables 7-1. And down here, this is table, I'm not sure because it's covered up in my image, so I'm sorry, but we have the table down below. And both of them are showing different pieces of information. Up above, it is giving you the radius of a falling droplet and the rate at which that droplet will fall. So that's its terminal velocity speeds. And down below, it is giving you bits of information about the distance before evaporation. So this is going to be the altitude of the cloud down here in this little area that I'm circling. And then next to it is the distance before evaporation. So how long till it'll evaporate, because really tall clouds will rain, but the rain will never touch the ground. It will actually evaporate before it ever falls. So question 10 says, in theory, how long would it take a large 50 micrometer radius cloud droplet to hit the ground if it was falling from the cloud base at 2,000 meters? And so up here, I'm going to look up my 50, and that gives me the cloud rate of fall at 0.3, and so that's 50, 0.3, so I'm just looking at my cloud droplet size, and we know that it's going to drop from a height of 2,000 meters. And so for this, I'm going to do a really simple equation of the height divided by the rate of fall. And that will equal time. So I'm going to put in my height of 2,000 meters, and I will divide that by my rate of fall at 0.3, and that will be meters seconds, and I'll get my answer in seconds. And that would be my answer for question 10. Question 11 asks how long would it take for a larger rain droplet to fall 2,000 meters. So you're going to do the same equation again, but you're going to use the larger rain droplet from the table up above. And then finally, down in question 12, they ask you approximately how far could a drizzle-sized droplet fall before evaporating. Well, that's pretty easy. I'm going to look up a drizzle-sized droplet. This is drizzle, 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 and they give me the radius. And then down here, I will look up my radius and see how long it takes for it to fall. So you're just using the tables accordingly to find the answers for question 12. All right, questions 13 through 16 are all going to deal with this table above. And in this table above, it's based on some very simple things. It's based on looking at two sides of the table. And on this side is the probability that you'll get drizzle at a particular cloud height. And this is the probability you'll get rain. Down here is the thickness of the cloud itself, and of course the thickness of the cloud is also a determinant as to how many rain droplets are present, right? A thicker cloud has more water. And if you notice, as the cloud thickness increases, the probability of rain increases. So as I go this way, the probability of rain increases. I get closer to 100%. On the other hand, the thinner the cloud gets, the higher the probability of drizzle will increase. And so in questions 13, if precipitation falls from a cloud with a thickness of 1 kilometer with a low base, what is the probability that it will be drizzle? So that brings me to the two other things. This dotted line over here is the clouds at heights of 700 meters to 1,400 meters. And over here, this solid line is clouds from anywhere on the ground, the surface, to 700 meters in the sky. So if I'm asking about low base clouds, I'm talking about ones near the surface of the earth. So I'm going to go for this line right here that I'm just attempting to highlight in green, but not quite lining up right with. So that's going to be the line I'm going to want to look at for low base. If I'm looking at high base clouds, then I'm going to want to look at the dotted line. So I'm asking low base clouds that are 1 kilometer. So I'm going to line up with 1 kilometer on my bottom here. I'm going to draw it all the way up to the solid line. And I'll look at the probability of drizzle, which will be a percentage on this line, versus the probability of rain. And I would write them in. So what is the probability that it will be drizzle? Well, I would say maybe about 90% probability. And what is the probability of rain? About 10% probability. So I would fill that in. Going to do the same thing for 14. And then 16, you're going to have the new cloud height, the higher cloud height, and work the same sort of answers for 16, but with the dotted line. So this is a pretty straightforward part of the exercise. All right, so question 18. Imagine a station when all of these forms start as snowflakes in the cloud, and then mark each form of precipitation to appear based on the temperature profile. Explain your choice for each example. So question 18, there's two parts. One is to label whether you think that the profile in A, B, C, or D is either snow, rain, freezing rain, or sleet, and then explain why you selected that one. So a little sentence next to it that explains it. I attempted with the little lines that are down here in the reddish color to put lines sort of where the 0 mark is because my temperature is in Celsius. So everything below 0 will be in snow form or ice crystal form, which means that if it stays below 0, it'll stay in its ice crystal form. Ice crystal form is also known as snow. So now knowing that and looking down here, I right away can see that the snow, the first one for snow, is going to be profile B, right? Because these are all negative numbers and it never crosses past the 0. Rain is going to be something that has to change or go past that 0 point into unfrozen water, into liquid, and stay liquid all the way through. And so looking at that, my profile right away for rain is going to be D, because it crosses over that 0 mark and it stays that way. So that's answer D. My next part for freezing rain has to be something where the temperature was cold, unfroze, and then refroze again. But it needs to be very, very quick or very sudden near the Earth's surface. And so I'm looking for something that's happening under 1,000 meters, that it's refreezing under 1,000 meters. And so I'm only left with A or C, but I can see that this one, the freezing crosses back over much higher, which means that it can get frozen again, where this one, the surface stuff is going to be unfrozen, and therefore it's down here. So freezing rain will be profile A. And finally, sleet, the last one left, will be something that unfroze and then refroze, but had time to refreeze on the way down, and so C as a profile works. Don't forget the second part of this question, which is explaining why you're going to line these up in their profile. Which brings us to our last set of questions, questions 19 and 20, which is a true weather forecasting question. 19 and 20 are asking you to look at this graphic down below, and right away in the graphic you have a little key right on this side that gives you different symbols, and it tells you which each one of these symbols are. One is the single dot says light rain, double dot is heavy rain, light snow is the crossing X, the double X's are snowfall, and then freezing rain is the little mark in between. And they basically say, give us a profile of what's going on. And what I like to do is kind of just create little lines so I can see what's happening with my weather station. I can see right here is sort of my definite snow belt. And then I can make another little line right here and say these people are going to get their freezing rain. And if the storm shifts, it can go south. And then finally, everybody below that line point down below near DTX are all in the rain zone. And so really what you're doing for 19 and 20 is just creating a little weather. You're just telling us what's going on in this weather map. Remember down below here, there's also this lovely chart that gives you the height and the temperature of each profile storm. And the APX is in the dotted lines, and notice it stayed below the freezing line again, because if I mark my 0, right, I can see that it stays below my freezing mark. And my DTX is going to be cold, but not necessarily always freezing, depending on how I'm looking at it. So I can even give you some temperature information. So write a few sentences that explains each one's profile and what's happening. And that's the lab. Best of luck.